Okay. So, I'm going to get my vertex first. My vertex is 1, 4. And I'm going to go right to my chart. 1, 4. Now, the 8 term has a denominator of 3. So I'm counting down by 3, and I'm counting up by 3. And these are the numbers I'm going to plug in. Negative 1/3, 4 minus 1 squared plus 4. Negative 1/3, 3 squared plus 4. 3 squared is 9. Negative 1/3 times 9 is negative 3. And my answer here is 1. So when I plug 4 in for x, my y is 1. Now I'm going to plug 7 in for x. Negative 1/3, 7 minus 1 squared plus 4. Negative 1/3, 7 minus 1 is 6 squared plus 4. Negative 1/3 is 36. Or negative 1/3 times 6 squared is 36 plus 4. 36 times a negative 1/3 is negative 12 plus 4, and we get a negative 8. So these are my points. 1, 4 to graph. Negative 2, 1. 4, 1. And then negative 5, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, negative 8. So this right here is the graph. Does it reflect over the x-axis? Yes, the a is negative. My domain, the x's are going to infinity in both directions. So it's negative infinity to infinity. The range, it's coming from negative infinity and going up to 4. So negative infinity, bracket the 4. Where is it increasing? It's going from negative infinity to the vertex, it's going up. The y is increasing as x is at negative infinity going to the vertex. It increases from negative infinity to 1. Remember, increasing and decreasing is about where it's increasing or decreasing along the x-axis. So therefore, it's decreasing from 1 to infinity. It's a maximum point. Just read the graph. The graph doesn't go any higher than the vertex. And that maximum point is the vertex. The line of symmetry is always x equals the x-coordinate of the vertex. And since my a is less than 1 and greater than negative 1, we have vertical shrink. And that's how the question will look on the test. My vertex, 1, negative 7. I'm putting that in the middle of my chart. 2 and 3, 0 and negative 1. So, 3, 2 minus 1 squared minus 7. 3 times 1 squared minus 7. I can't stress enough. You square the 1 first. It's not 3 squared. It's 3 times 1 squared. So when x is 2, it's negative 4. When x is 0, it's negative 4. Do 3. 3 times 3 minus 1 squared minus 7. 3 minus 1 is 2. 2 squared is 4. 12 minus 7, we get 5. And now I'm applying those points. 1, negative 7. 1, 2, 3, 4, 5, 6, 7. 2, negative 4. 0, negative 4. 3, 5. 1, 2, 3, 4, 5. Negative 1, 5. And you can tell this graph is going to have vertical stretch, which it should. The a is bigger than 1. It does not reflect over the x-axis. It opens up. The domain, negative infinity to infinity. the range. We're going to bracket that y coordinate. -7 to infinity is my range since this is going up. It increases from the vertex going to the right. So the increase is from 1 to infinity, which means the decrease is from -infinity to 1. If I start at -infinity out here and go down, -infinity, it keeps going down until we hit 1 on the x-axis, and then it goes back up. Max min point, it is a minimum point, and it's the vertex. My line of symmetry is x equals 1, and obviously this is vertical stretch. So, to get our vertex, which is where we start here, we've got to use -b over 2a. My a is -2. My b is 8, and my c is 3 from the ax squared plus bx plus c basic trinomial formula. So when I plug those numbers in, -8 over 2 times the -2, that gives me a positive, because there's two negatives, 8 over 4. My x coordinate is 2. Then I literally plug the 2 in for x. -2 times 2 squared plus 8 times 2 plus 3. 2 squared is 4. It's not 4 squared or -4 squared. You've got to do the exponent first. And now it's -8 plus 16 plus 3. Okay? -8 plus 16 is 8. 8 plus 3 is 11. I'll make sure on the test this doesn't fly off the graph. So 211, we're going to put that point right here. I'm plugging 0 in for x. We always plug 0 in, and you get that constant. So when I graph this, this is 0, 3. I went over 2, I'm going over another 2. Use the graph to get your third point. It'll be the same y-coordinate, and the x will be the same distance on the other side of the x-coordinate of the vertex. So we're at 0, 3, 2, 11, so I went 1, 2, over another 2, because these graphs are symmetric. And from these 3 points, I can draw my graph. And now I'm just reading my graph. Domain, -infinity to infinity. Range, -infinity to 11. Where is it increasing? From -infinity going to the right. It's increasing from -infinity to 2, so it's got to decrease from 2 to infinity. It's a maximum point. The line of symmetry is x equals 2. It's always the x-coordinate of the vertex. And since the a term here, just like in vertex form, the a term here is bigger than 1. Or the absolute value of the a term is bigger than 1. Remember, the a term is bigger than 1 or less than -1. We have vertical stretch. And just look at the graph compared to what the parent graph would look like. This graph is going down quicker. There's no question about that. All right, so my -b over 2a. All right, so my a is 3, my b is 6, and my c is -4. -6 over 2 times 3 equals -6 over 6. It's a -1. So my x-coordinate is -1. 3 times -1 squared plus 6 times -1 minus 4. -1 squared is 1. And as you all know, I like to just do that step separately. 3 minus 6 minus 4. 3 minus 6 is a -3. -4 minus, or -3 minus 4 is a -7. So that's my vertex. -1, -7. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay. what's my y-intercept going to be? If I plug 0 in for x, I'm going to get -4. So when I graph that point of -4, I went to the right one from the vertex, now I got to go to the left one. So it's -2, -4. And that right there, my friends, is my graph. My domain. -infinity to infinity, because every domain goes from -infinity to infinity. I can get any number in for x I want. The range, we're going from -7 to infinity. It's going up. Anytime our graph goes up, we're decreasing from -infinity to the x-coordinate of the vertex, which means I'm increasing from the x-coordinate of the vertex to infinity. Max min point, since it's opening up, it's a min point, and -1, -7. My line of symmetry is x equals -1, and my a is greater than 1, and I think it certainly looks it with the graph. The graph has vertical stretch.